So lesson 7.3 seems like it's going to be a little long, but I'll do my best to make it as short as possible. So let's get talking about it. First of all, we're going to discuss the means and variance of random variables. And one thing I want you to know is that when you see e of x, it's going to be the expected value of a random variable. And that's really the mean, which in this case is mu. Now remember, because we'll go on. But because it's a Greek letter, actually we're talking about the population. So there you go. The variance variable is equal to sigma squared. And remember, the standard deviation is, the variance VAR of x, is a standard deviation squared. So I'll give you half a second to write that down or pause the video, and then I'm going to go on. So here is the book definition of what a random variable, the expected value of a discrete random variable. So it says we multiply these things together. See, x1 times p1, x2 plus p2. We add them up, and that gives me my expected value, my mean. So I'll give you a second to write this down. So let's take a look at how this actually works. So here's something. It says a number of broken eggs in a carton of a dozen eggs is described by the random variable we see below. And we have to find the expected value. So let's see how to do this. So we multiply 0 times 0.65, that's a probability, plus 1 times 0.2, plus 2 times 0.1, plus 3 times 0.04, plus 4 times, and what number goes here for 4? It's 0.01, right? Unless I added that up wrong. Let's look at it again. 65, 85, 95, 99. Now we're at 100%. So it's 4 times 0.01. That's an O. So let's take a look what all this is. This is 0 plus 0.2 plus 0.2 plus 0.12 plus 0.04. We add these up. 0.2 and 0.2 is 0.4. 0.52, 0.56. So that means we expect half an egg to break on each carton of eggs. Now that might not make sense unless you're talking about, say, thousands of cartons of eggs, or let's say maybe 100 cartons of eggs. In 100 cartons of eggs, we'd expect about 56 eggs total to be broken. So maybe if we needed 100 dozen eggs, we'd know we have to order some extra eggs in order to fulfill the recipe or whatever we needed. So that's how you work an expected value. If you need to, you can watch it over again, but hopefully you're fine. Now let's look at the variance of a discrete random variable, and here's how it's defined. And what this says is it says that the variance is equal to the sum of each of the xi's, and I'll show what that is in a minute, but that's basically like 0, 1, 2, 3, etc., minus the mean, and it's of x, that's all that x means, squared, times the probability that that event is going to occur. Okay, let's take a look at this so we can figure this out a little bit. So we already know that the expected value, the mean, is 0.56. We figured that out just a second ago. So I'm going to show you how to square. I'm not actually going to do the math, but you can. So here's what we have. We have x, which is 0, minus 0.56 squared times 0.65. That's the probability that event occurs. Plus 1 minus 0.56 squared times 0.2 plus 4 minus 0.56, squared, and this would be times 0.01. And when we're done, we take the square root of all of this to get the standard deviation. This is the standard deviation. And of course the variance is just equal to all this without the standard deviation. I hope that helps a little bit. If not, ask me in class and I'll go over it again. Let's talk about one more thing now that we're at this discussion, and that's the rules of means and variances, because the means and variances rather have some rules that go with them, like how to add things to them. So here's the first thing, it's the rules of means. What this says is you have some mean and you add a to this mean and you multiply it by x. We just add some value to it and we multiply the mean by b. We have the mean of two different things, we can just add them together. And this one, the bottom one, I really think is the easiest. For example, if I told you I have a cart sells on average 3 hot dogs and 5 hamburgers, so that's the average would be 3. And this one would be 5. How many hot dogs and hamburgers do they sell? And it seems to make sense that you add them together and get 8. Seems to make sense. Okay. And let's take a look at the rules of variances. This looks a lot worse than it is, but let me give you the basics of it. If you add something, it doesn't change the variance. If you add something, it doesn't change the variance. However, if you multiply something by the variance, it's the same thing as squaring it. Okay. There's a reason for that. Maybe we'll talk about it in class if I remember. Maybe we won't. Also, I want you to notice these two formulas. I want you to notice something. It doesn't matter if you add or subtract variances. We will always add the variances. Now this thing at the bottom, this is a row. Oops, that's a 2. That's a row there. And what that means is if there's a relationship between x and y, we have to add this thing in. This formula is not used very often, and you'll know about it. They'll tell you something like, they'll give you some value for row, so you'll be able to see it in the problem. These rules here only apply when we're independent. So when these are independent, this rule applies. If it's dependent, they'll give you some value for row, and you use the bottom formula. Generally, you're safe if you don't know using these two formulas here. Just please remember, we always add standard deviations. If you look at standard deviation as a little bit of an error, because that's what it is, you have to ask yourself, do you think errors ever reduce, or do errors always propagate or increase? And the answer is errors always propagate or increase. So I'm going to do a sample problem. And here it is. And it says for a test, the score is given by the sum of the multiple choice and the free response questions. And here it all is here, mean standard deviation. I know it's formatted odd, but this is standard deviation. I apologize for the bad formatting. So the standard deviation is 6 for multiple choice and 7 for free response. It says find the standard deviation of the average test. So standard deviation is really the square root of the variance, and we cannot add standard deviations. So the only way we can add up these two standard deviations are variances. And we just learned in order to do that, we are going to have to square them and add them. Oops. Well, see, I already put the answer, but anyway, we square it and add it. I'll change this a little bit to make it a little easier. There we go. And I put my pen back. There we go. So this is 36 plus 49. If we add 36 and 49, we should get 85. And that's our variance. But it doesn't ask you for the variance, it asks you for the standard deviation. So if we want the standard deviation, we take the square root of that value. Oops, let me get rid of that squared sign so we know it's a standard deviation. So standard deviation for this test is the square root of 85. We square them, sum them, and take the square root of them. Another way to think of this is that standard deviation, if we look at a graph, is a distance from the center. So if we're talking about distances and we wish to add two distances together, easy for me to say, we have to use something like the theorem, where we add two things together, we square it, add it together, and take the square root of it. So if you think about standard deviation as being a distance from the mean, then it makes sense that we have to first square it, and then sum it, and then take the square root of it. Okay, that was 7.3. If you have any questions, you can watch it again, or please ask me questions in class. Good luck.